Hello everybody. My name is Datis Andersson, and today I'm representing one of the CLIMAAX project pilots. I'm representing Latvia. So I'm data analyst from Latvian Environment Geology and Meteorology Center. So mainly I'm working with climate change data and doing all kind of stuff with analyzing it, like past changes in the climate and future predictions and so on. But today I'm gonna give you a short look into what we are doing in this project and how CLIMAAX tools are helping us to improve our climate risk analysis and how we are dealing with different kind of questions while working into this field, into climate risk analysis. So first of all, as I mentioned in the first slide, I'm a data analyst. It means that for me, maybe that technical parts which are in the project and technical parts like a toolbox and codes, they are quite understandable for me. But then there comes the framework part, and that is the part which is tricky for me. And that's why we are mainly trying to do actually the tricky parts, and we are taking us outside of the comfort zone. So this is the framework, and this is something what we as a pilot are mainly working with, so we can understand each step in the framework, so we can answer to different kind of questions, what is actually in the framework and what we should do. In this presentation, I will try to go through the framework so that you can understand what we are, how we are looking at it, and how we are trying to do it step by step. So first of all, there is a scoping phase where we have to think about climate risks, what we have. So in Latvia, we have different kind of climate risks, started from the dry periods and with the hot weather and wildfires, and then there are floods based in precipitation or river floods, and of course heat waves and so on and so on. But of course, in the project or in the real life, we have to start with just one climate risk. So in my opinion, if you understand one risk and the way how to go through climate risk assessment, then it's easier for other risks to implement the same steps. The first phase, as I mentioned, is the scoping phase. So at this phase, we were trying to think about our climate risks, and we were trying to think about which risks we want to, where we want to start. So we started with the floods, with the coastal risks at this time. So my presentation will continue with mainly with these risks. So I will give an example how we are going through the framework if we're talking about coastal risks. So why the coastal risks? Because in Latvia we have quite a long coastline. It is more than 500 kilometers long coastline, and it's mostly loose and sandy sediments, and those sediments are quite vulnerable to coastal erosion. And another thing is that based on future climate change scenarios, it seems that in the future, sea level will rise even faster. And it means that we have to start to think about this problem right now. Otherwise, when it will come, it may be too late. So that was the scoping phase. Then the next phase is the risk identification. And here, actually, the next step is coming into the game. There is this CLIMAAX toolbox, and with the different kind of workflows. And there are workflows about floods, droughts, heat waves, fire, snow, wind. And if we're looking at this specific coastal problem, then we can use floods workflow, and that is what we are using. And in the floods workflow, actually, there are two different workflows. One is for the river floods, and another is for the coastal floods. And into these two workflows are two different scripts. First script is giving us results of the hazard assessment for retrieving flood maps. And after running this code, we can run another code, and that code is giving us risk assessment for mapping potential damage. So yeah, this is what we are working with. We are working with these two scripts, and what are the results? So here is another step, which is risk analysis. So here are first results, which came out of the toolbox, which is in the GitHub. This toolbox is in the GitHub. So if we're running these scripts, just changing coordinates to our own coordinates, then these are first results. These are flood extents in extreme water level scenarios with different return period. And yeah, those are two maps for one of places in Latvia called Bernāti. And yeah, it was quite easy to get these maps. Just change coordinates and click enter, and this is something that you can get out of the toolbox. And then there is this another script which you can run and get these kind of results. So this is for the Riga, our capital city. So in the middle you can see flood depth for 1 in 100 years. On the right side, there is Luisa land cover for this area, so you can see how different kind of land covers we have in Riga. And on the other side, on the left side, there is flood damage for 1 in 100-year return period. So we can get these kind of information also out just by changing coordinates and getting all this out of the toolbox. And everything looks very nice and beautiful, but we all have to remember that these workflows are based on the global data. What does it mean? It means that there might be some times when global data isn't working that well. So you need to add your own knowledge, you need to add your own data to improve all of it. So here is one example where there is on the left side, you can see what the CLIMAAX flood workflow gave me when I run the script, and everything looks quite nice, and resolution also is very good. But on the other side, there is the same maps, but based on our own knowledge, what our hydrologist made. And when I ran the CLIMAAX script and looked at our map, I saw that here are some differences. For example, here in this area, as you can see, there are floods in both maps, but in Latvian case, then their floods just stop. And of course, when I saw this, I immediately called our hydrologist and wanted to hear why is that and what's happening there. And then he told me that he knows this, and the reason why in our own maps the flood stops right here is because there is a line where used to be train tracks, and now there are like banks, like a small mountains there, and our hydrologists are saying that the floods won't pass this in the storms in 1 in 100 years. So it's like a local knowledge what we can add, and that is something that is we can know it, just local people can know it, and just people who actually are working with the data and knows the place can add it into and make it more local to exact place. So here are other things that we can add into this analysis, such as, for example, we have analyzed sea level rise in Latvia, so we have bias corrected based on our station data, so we can add this kind of information. And we also know what is happening, like we can look through the media and see how it correlates with the actual situation and so on. So this is the local thing, what we all have to remember, that global data are very nice, but if we have some regional knowledge, it is even better. Then after risk analysis comes next phase, which is called key risk assessment. When we started the project, we got a few questions from our colleagues, and at first they seemed like normal questions, we can answer them, but if we really were trying to answer them, we understood that we don't have the knowledge because there sometimes are some difficulties when we need other institutions to join us, and so we can answer these questions all together. So here I wrote down some of institutions in Latvia to whom we are right now talking to, and for some we will talk to. So all of this is like a cooperation. We as a Meteo Center, we cannot answer these questions in a very good quality, so we need colleagues from other institutions to join us so we can all work together and all improve this climate risk assessment. Then there is another phase called monitoring and evaluation. So this is the monitoring part. A few years ago, we got a new cabinet regulation about climate change monitoring, and in this regulation there is also a section about sea. So we as a Meteo Center, our responsibility is to do monitoring to the average sea level and also coastal erosion. So this is something that is already written in the regulation. It means that there is also money left for this, so we can do it, and we are doing this monitoring. And then there is a very new law, which is actually not out there yet, but we are already preparing information and preparing algorithms for this. So we will monitor sea level and recalculate the buffer zone when it will be necessary. So this is very new. So yeah, it is very nice that we are really starting to do monitoring for the climate issues based on the coastal things. So, and then there is risk evaluation phase. Unfortunately, everything here is in Latvian, but actually in this case, it doesn't matter because everything that's written there isn't about coastal erosion or accumulation or anything like that. This information here is based on another field. So a few years ago, we had a project where field experts were looking at their data and our climate meteorological data, and they were seeing correlations how based on climate change are changing some of their indicators. And this is something that we have for the 6 fields right now, but unfortunately not for the coastal processes. A good thing is that we are monitoring right now these processes, so a few years from now we can make this kind of evaluation also for the coastal processes, so we can see how actually climate changes are affecting all of it. And then again, climate risk assessment framework. Why I added it also here, because after monitoring and evaluation, there you can see an arrow to the scoping phase. It means that this actually is like a never-ending circle, because again, we have to do scoping, risk identification, and so on, because this time we know more, we have more knowledge, we have more data because we started to do the monitoring part. So yeah, this is something what we will do in the future as well. We will keep going through the circle, this time with more knowledge, with more data, and yeah, each time we will improve the system and have better results. So that was my experience from this project. As I said, we are mostly technical people, so we are really a bit scared of what we are doing here with the framework, but we are improving it more and more. So we have to contact a lot of institutions in Latvia, talk with many different institutions to improve it. It is challenging, but that is climate change, and climate change really is challenging for all of us. So yeah, thank you.